Hello and welcome to this video on an interesting aspect of the New Horizons space probe. The New Horizons space probe was sent to make a flypast of Pluto and thereafter to fly out into interstellar space. However, as well as observational work, NASA took the opportunity to do two other experiments. Those two experiments were one, measuring parallax, and two, experimenting with working out New Horizons' position in terms of stellar coordinates, in other words, stellar navigation. This video is concerned solely with making parallax measurements because to include the navigational work would just make the video far too long. So in this first image, you can see two stars, Proxima Centauri and Wolf 359. Towards the bottom, we have Pluto, then the New Horizons probe. Coming away from the probe is a line which links the probe directly to Earth. The significance of that will be on the next image. Now, if you are a Star Trek Next Generation fan, you may know the significance of Wolf 359 and the battle with the Borg. So on this second image, we have at the top the Earth and Proxima Centauri, and we're measuring the parallax of Proxima Centauri from Earth, which is shown as the angle alpha. To the right of the top half, we have a Gaussian graph. Now, the value of alpha from Earth of the Proxima Centauri is really just a fraction of an arc second. So what's the problem with that? Well, the problem is that that sort of angle size is considerably smaller than the point spread function. So what is the point spread function? Well, that is the Gaussian-like graph shown on the right-hand side there. Now, when you focus an image for a piece of optical equipment, you'll get an intensity profile, keeping it as simple as I can, and that will be what we call the point spread function. Now, the point spread function is going to be different for different telescopes and cameras, etc. However, whichever piece of equipment is being used, the point spread function is going to be significantly larger than the angle alpha. So, in other words, the angle alpha of the star, Proxima Centauri, can't be measured directly from Earth using telescope. You have to go through a certain, not complicated, but involved sequence of numerical analysis to get the parallax. So switching to the bottom half of the image, here you can see that the angle is being measured relative to the New Horizons and Earth baseline. What is immediately apparent is that alpha is considerably larger. So in other words, using the New Horizon probe, NASA were able to make parallax measurements directly. NASA chose these two particular stars because they were relatively close to the New Horizons probe, and that meant that they would move against a fixed background of more distant stars. The two stars chosen also had a particular characteristic, and that will be shown in the next image. So with the New Horizons probe moving ever further away from Earth, the obvious problem of measuring parallax, or in fact anything, is one of communication. So if the New Horizons probe makes a measurement of parallax on a star, it would then send that information to Earth, and Earth would process that information and then make the parallax measurement themselves. Now, the obvious problem there is that with these two stars being moving significantly against the background stars, by the time Earth makes their measurement, the star will have moved, and therefore they'll get a different parallax reading. So how to coordinate things? That is where the second characteristic of the stars I mentioned earlier comes in. Both Proxima Centauri and Wolf 359 are known as flare stars. In other words, they have significant prominences emerging from their surface. So on this image, you can see there's a prominence coming from Proxima Centauri, and both New Horizons and Earth make the measurement at the same time. So in other words, by observing some common event or obvious event on the surface of the star, the Earth and New Horizons probe can make measurements at the same time. Now, if the stars were not flare stars, this would have been much more difficult, if not impossible. So this fourth image is split into two halves. At the top, you can see the image of Proxima Centauri as it would be seen from Earth, and at the bottom as seen from the New Horizons probe. In other words, there's an obvious shift between the Earth observation and the New Horizons observation. Note, however, that the background field of stars is fixed. Now, the coordinates of these background stars were known very accurately, and those coordinates were obtained from something called the Gaia DR3 catalogue. The problem with that catalogue is it was made at a different epoch to the New Horizons epoch. So the Gaia DR3 coordinates had to be transformed from the 2016 epoch to New Horizons 2020 epoch. As you can see in the text towards the bottom of the image, the coordinates of the background field of stars were made to an accuracy of 0.1 of an arc second. The requirement was to be within 0.18 of an arc second. So in other words, the coordinates were very precise. Now in this final image, which is just text, these are the steps which the images of Proxima Centauri and Wolf 359 would have been processed through. Now, if you have an interest in astronomical photography, these terms will be very familiar to you. So the images would have been rotated, scaled, stacked, and then stretched. Now the stacking of the images tends to average out noise, any noise in the image. The stretching of the images expands the intensity profile of the image. Another important manipulation that was carried out was correction for the point spread function. The images taken by the New Horizons probe were taken using its LORRI camera, LORRI, which is a not particularly advanced camera. So in other words, it has quite a coarse point spread function. So the images on Earth had to be processed to take account of that. So the images were also convolved with a Gaussian profile that closely duplicated, as far as possible, the New Horizons probe point spread function. Now, this is all very interesting, but perhaps the most interesting thing you'll find related to the processing of images is the fact that one of the authors on the paper and the person who did the work on the images was one Brian May. Yes, Brian May of Queen. And his name is there on the list of authors of the paper. Excuse me. And the link to the paper I've put below the video. So anyway, thank you for watching this video. I hope it's been of some interest for you. If this video has been interesting, then please consider subscribing. Anyway, thank you for watching.